Hello, Eric here, and welcome to a computational science video tutorial. This is going to be a part of a series of videos designed mainly to help my students visualize data for a final project. If you're not one of my students, I hope this is useful to you. What I'm going to do is I'm going to create data in C++, and then I'm going to visualize it with Python and then with Matlab. So I'm not using C++ for the visualization, just for the generation. Also, I'm using CLion. I'm not going to talk about the features of CLion at some point. I may want to create a series talking about CLion. If you're interested in that, please leave a comment and I'll get around to it. All right, so let me create the data quickly. My students, you should be creating this data for your final project, but if you watch this, it might give you some insight as to how to put that data into a file so you can read it into Python easier. All right, I'm going to start by creating a header file. I'm going to right-click, create a C++ header file. I'm going to call it generate data. In my generate data, I am going to need a couple headers. I need to use, let me make this bigger. I'm going to need vector, and I'm also going to need, let's see, fstream. And I think I need string as well. Oh, I don't like this being, there we go. So I need vector fstream, which is going to be for writing a file, and string for using string objects. All right, the first thing we want to do is I want to create something here to linearly space the data for me. So I'm just going to quickly write that up. Void linear space std vector double. And I'm going to pass it by reference just to make life easier. We're also going to need to know where the beginning and the end point for this linear spacing. So we might start at 0 and linear space up to 1. So it'll go from 0 to 0.1 to 0.2 to 0.3. So we want to do something like that. Maybe we'll go from 10 to 20. So we want to be able to choose any range. So double begin, double end. That's going to be the beginning and ending. Now size is going to be the size of the vector we're working with. I'm going to split this up over a couple lines here for the input just so you can see it. All right, so we have a beginning, ending, and size. We want to keep track of how much spacing is between each element. So if our vector has 10 elements in it and it goes from 0 to 10, we're going to want to create the right spacing there. So for this dv, we're going to have to compute this. So we're going to start with do a little arithmetic, end minus begin, which is going to give us the length of the interval, of the total interval, I should say. And then we want to divide it by the length of each subinterval, since this is linearly spaced in an even way. And if we have 2 points in our vector v, we're only going to have one interval. If we have 3 points in our vector v, we're going to have 2 intervals. So the number of intervals is our size minus 1, and that's how we're going to compute our dv. Second, we want to make sure that our vector v is the right size. So I'm going to do v dot resize, and we're just going to set it to the size that we're asking for. Then we're going to do a for loop, auto completed by CLion, which is awesome. Some quick tabbing through using CLion functionality for quick coding. I love that. Hopefully everyone knows how to make for loops though. If not, please check out some simple videos. All right, vi is going to equal, begin plus I times dv. All right, so I will start at 0, so it'll start at the beginning, and it'll keep go through by the dv. We've created dv so that the final I should put us right at the end. So this will linear space our data. Next function we need to write, we'll write our vector to a file. So I'm going to call this void write vector to file. So first thing we need is a string for the file name. Second thing we need, I guess we'll do it like this. So we need a string for the file name, and then we need a constant vector. And I'm going to split this onto 2 lines so everything's easier to see. All right, and what we're going to do is we're going to open our file. So I'm going to say std of stream file, and we're going to open it. It's going to be file name std ios out. Now we don't need this std ios out. I like to include it just to keep it a little bit more clear. Now if our file is open, what we want to do is we want to keep writing it. If it doesn't open, we don't want to try writing to it. We should probably do some error handling. I'm going to ignore that for now. So if the file is open, we're going to write it. So we're going to say for I is less than v.size. Since it's a STL vector, it knows how big it is. And we're just going to do file v, and then we'll use the appropriate end line for our system. Oop, I said v, it should be vi, the ith element of v. And every line is going to have one element of v. So we're going to think of this as sort of a column. If you have two elements of data, you can try to put two elements here, and then when we go to Python, you can just read them in using a similar methodology. Once the data is finished, we're going to do file.close, and we're done. So we can jump back to our main program, and we can start the program. We are going to need, let's see, I'm going to want to use vector, and I'm going to want to use, because I'm going to create a function, I'm going to use cmath for the math functions, and I want to use the header I just created. All right, so these are our includes. Let's create our vectors, std vector double x. We'll create another one for y. We're going to create x as a linear spacing. We're going to give it x from 0 to 10. Why don't we have 11 spaces in there? Then it'll be even. We'll do 21. I like 21 better. Then we want to make y to be the same size as x. So I'm just going to resize y so it's the same size as x. Now what we want to do is x has this linear spacing, y has the same size as x, so we want to fill y using a function of values in x. So I'm going to loop over everything that is in x.size. I could just as easily say y.size here. They should be the exact same size. And we want the ith element to y to be equal to something based on x. So I'm going to use std size. I'm just going to look at the sign of xi. Just a simple sine function. This should be easy enough. Now I want to write these to a file. So I got to create file names. So I'm going to create a path to my local directory here. I'm then going to create something for my x file, which is going to be path plus x.txt. And then I'm going to create my y file very similarly. For my path in C-line, we can just click on our directory here and copy our path. And then we paste our path here. Make sure to put our end symbol at the end, and everything is exactly as we wanted. Now we just need to write to file. So we just use our write vector to file functionality. Our file name is going to be x file, and we're going to write x. Then we're going to do our write vector to file again, and we're going to do our y file and y. At this point, we should be able to run our program, and it should generate our two files for us. All right, and look at that. It's finished. We have toted our files. Let's see. Sometimes we have to refresh up here, and we can see we have our x file. We double click on that. We have the outputs we expect. We double click on our y file, and we have the outputs we expect there. So using our simple main function that was assisted with our generate data, we're able to create our data. So in x and y, we have a file for x, everything in one column, and a file for y, everything in one column. Now what we can do is we can move on to our secondary software like Python or Matlab and visualize there. So I'm going to end this video now and move on to the next one. If you found this video useful, please leave a like. If you have any questions, send me some comments. And if there are any topics you'd like me to cover in future videos, let me know in the comments below. All right, thanks for your time and have a great day coding.